Hello everyone and welcome back to MIS 5000 Special Topics in MIS. Today we're going to finally introduce the Python programming environment, take a look at the basic types in Python, and go over how to take user input and provide user output. The learning objectives for this module include the following. So after this module, you should be able to describe the advantages of computer programming and the Python programming language, explain the order of operations of Python math operators, use Python math operators in an application, define the integer, float point, and string data types in Python, define and implement string concatenation in Python, define the concept of and implement variables in Python, define and implement variable casting in Python using the int, float, and string functions, and finally, implement basic user input and output in Python. As a reminder, here are the 4 basic pieces of programming logic discussed in your textbook. We're going to tackle the first of these in this module, so simply do this, then do that. This will include anything from using variables to perform mathematical operations and other processes, basic input, processing, and output application. We have already discussed how to perform the additional pieces of programming logic in flowchart form, and we will get to that in Python code in future modules. We've already discussed the importance of the flowchart as being a component of communication between technical and non-technical users. Another important component of communication in Python is that of the comment. So before writing any actual code that performs an action, I'd like you to consider the 2 different kinds of comments that can be made in Python. So this is code that will be written but will not be executed to any degree in the language. If you'd like to simply write one line as a comment out a line, you will use the hash. If you would like to include an entire block of text as a comment, simply put 3 double quotes before it and 3 double quotes after it. Not only can you use Python comments to mark up different pieces of code to let others know what they perform, but you can also use comments as a means of testing your code to see what certain blocks do and to test whether or not certain blocks are working in the way that you expect them to or not. We have mentioned the idea of a data type previously, and now we're going to see this in action in Python syntax. So every variable has a data type. Once it is given a value or casted, it will receive a data type. Python uses the following data types: integers, floats, strings, booleans, lists, tuples, sets, and dictionaries. Some of these are primitive data types, and some of these are more advanced data types that we will use later. It's important to know what kind of data type you have, because that will let you know how it will behave when you use mathematical operators with it. The data type indicates what kind of value it can hold and how it can be used. Let's talk a little bit more in detail about the different data types. Specifically, today we're going to focus on strings, integers, and floats. Strings are alphanumeric values that look like words or sentences to the human eye. Strings must be enclosed in single quotation marks. We have a few examples of just one character. We have examples with spaces as well, because remember that a space actually counts as a character in a string. We also can see in the phrase "meet my 11 cats" that the number 11 here is not treated as a number, but is treated as a string. One thing to keep in mind as we begin to take user input is that the input function in Python, whatever comes into that and is stored in a variable, will come in as a string. So if you're wanting to process something that the user input as an integer or a float point, you will need to cast it. And we'll see an example of this shortly. We will be working with 2 different kinds of numbers in Python: integers and floats. Integer values do not have fractional parts. This is very similar to the concept of an integer in mathematics, the exception being that we do not have infinite numbers in this case. We're bound by the size of the data type. Some examples include the number 5, the number 100,001, and the number -429. Any value that has a fractional part or values to the right of a decimal is considered a float value. Examples include 10.0, -20.555, and -0.09. Keep in mind that there is a difference between setting the variable x equal to 10 versus setting the variable x equal to 10.0. The latter will be treated as a float data type, and 10 alone without the fractional part will be treated as an integer. We've discussed variables a little bit before. Remember that variables are containers for data. Similar to these Tupperware containers, you can see that they come in different sizes, meaning they can hold different data types. You can imagine putting a label on each of these Tupperware containers because each variable has a name, it will have a data type, and it can be assigned a value. That value can change over time within the program. You can name a variable anything so long as it follows 3 rules. The first, it can only be one word. Variables can't be more than one word. Once you add the space, it will consider that to be a new piece of code. A variable name can only use letters, numbers, and the underscore character, and it cannot begin with a number. Here are some examples of valid and invalid variable names. So in the valid column, we have balance balance with an underscore. You can start a variable name with the underscore, like underscore spam. Variable names can come in all caps, and they can end with numbers. They cannot, however, use the hyphen, include spaces, begin with a number, use certain special characters like the $sign, and of course the last example here, hello in single quotes, is going to be treated as a string. It is not a valid variable name. So in math, when we see an equal sign, we're thinking about equality. When you see an equal sign by itself in Python programming, we are thinking about assignment. So we use the equal sign to assign a variable a value. For example, you can see here x equals 3. What this is really saying is that x, which is on the left, is going to be assigned the value of 3. Similarly, my name equals Jolene. So my name will receive or be assigned the value of the string Jolene. Finally, balance is equal to 21.0. The variable balance will take on the value of 21.0. And here you can see we have an example of the first being an integer, the second being a string, and the third being a float point value. We have already used some mathematical operators in our flowchart examples. These can be seen on the right. Mathematical operators can be used to perform mathematical operations on integers and float point variables. The order of operations applies from top to bottom in importance in the chart. So you can see that exponents are evaluated first, then the modulus, integer division, multiplication, subtraction, and addition. Notice the difference between integer division, which is the double division sign, and simple division. All division that is basic division in Python 3 will result in a float point value. So for example, the integer 3 divided by the integer 3 will produce 1.0. If you are looking for a floored quotient, or to produce an integer out of division, you'll need to use the double division sign. So you can see 22 divided by 8 is 2. You can perform mathematical operations on the right of an equal sign. The result will then be assigned to the variable that is on the left. When using the equal sign in Python programming, the variable on the left takes the value or expression value on the right. And you can perform any mathematical operation on integers or floats. So for example, x equals 3 times 5 will result in the value of 15 being assigned to x, the integer. Number equals 10 mod 2. Remember that modulus gives us the remainder. So 10 mod 2 will result in 0 being assigned to the variable number. And finally, in Python, once a variable has been assigned a value, that variable can be used in a new expression as well. So if we take these 3 lines of code in succession, we have x equals 15, number equals 0, and finally y equals x plus number. After the expression on the right, x plus number is evaluated. It will evaluate to 15 because 15 plus 0 is 15. That value will then be assigned to the variable y. Again, in Python 3, all division using the basic division sign is float division. So for example, 3 divided by 3 will produce 1.0. Not just 1 without a 0, and the integer 3 divided by the float point variable 3.0 will also produce 1.0. The nice thing is in programming, if you're ever in doubt, you can simply run a test to see what you're getting. You have already used the print function to print to the console in our first Hello World program. We'll get into detail more about how functions work and how you can define your own functions later. However, just understand that we know print is a function because it's followed by parentheses, and whatever argument we put inside those parentheses, for example, a variable that holds a string, an integer or float, or simply a string, that is what will be printed to the console. You can print values and variables of different data types to the console. However, you may get errors at this point if you try to include variables and values that are different data types. Here are a few examples of printing values. We can simply print 3. We can actually perform mathematical operations inside functions as well. So print parentheses 3 plus 3 will result in 6 being printed to the console. And finally, we can print strings like print hello. We enclose it in single quotes. We're now going to take a look at a couple of examples in Visual Studio Code. We'll write a few very simple programs using some operators. I'll show you some mistakes that can be made, and then we'll go ahead and turn our first 2 flowcharts into applications in Python. So first we are going to assign the value of 2 times 4 to the variable num1. We'll then assign the value of 3 plus 7 to the variable num2, assign the value of num2 mod num1 to num3, and finally we'll see the final result of num3 as we print it to the console. I've gone ahead and copied this text, and I'm going to show you how to comment it out in Visual Studio Code using the block comment. Let's go ahead and head back to Visual Studio Code. I've already shown you how to open up a folder in a previous video. If you don't remember how to do that, you can simply go to File and Open Folder. This will select a folder for you to store your Python programs in. We already created our first program, our Hello World program. Notice again that it has the file extension py to indicate that it will be recognized and treated as a Python application. I'm going to go ahead and right-click in the Explorer and create a new file. I'm going to call this module6 examples.py. And then I'm going to go ahead and use the triple quote to include a block comment with the different operations that we want to perform. So you can see at this point a few things. Next to the file name, we have a white circle. So the white circle indicates that I've made changes in the file that have not yet been saved. I'm going to do a Control S, or you can also go up to File Save. You'll see that that circle disappears. This is really important because you want to know that the final save state that you're in is the state that you're going to run the program in, so that if you're trying to debug, you won't, for example, think that the program should be doing something that it really isn't going to do because you haven't saved it in that final state. So do make sure you save or you make a copy if you want to hold on to that code. Let me go ahead and hit the run button, or you can also do a Control F5, and what you'll see is that absolutely nothing happened. This is what we expected because all we've done so far is written a comment. Let's go ahead and take care of this first operation. So we want to assign the value of 2 times 4 to the variable num1. I'm going to put num1 as my variable name on the left and use the equal sign, which represents assignment, and then simply write 2 times 4 after it. Remember that the multiplication operator is going to be that star or that asterisk. At this point, if I wanted to see the result, I could easily print it to the console by simply typing print num1. You'll see that certain extensions that I included in Visual Studio Code are offering me autocompletes. So it's offering me different autocompletes for different functions, among other things, as well as the variable name we actually created. So if I really wanted to, I could click right here and it would autocomplete num1 for me. I'm going to do a Control F5 to see the result, and you can see at the bottom of the console we get simply 8. I'm going to show you one other thing while we are here. Let's say we want to actually print out a sentence that then explains the value that we received. What we're going to have to do here is what is called string concatenation. So a note here is on data types that it is up to you to manage the data types of your variables. So we've created num1 and we've set it equal to 2 times 4. That is now an integer variable, and it's something that you need to keep track of and keep in the back of your mind. I'm going to put a comment here that indicates that that is an integer variable, since that's the thing that we're discussing right now. Let's go ahead and start that sentence to print to the console. In order to do that, I need to create a string, so I'm going to use a single quote and say 2 times 4 equals, I'm going to add a space, end my quote, and then add a plus sign before num1. So let's discuss what's going on here. First, we have this string, 2 times 4 equals, including a space after it. The idea of string concatenation, which I'm going to write here, string concatenation is that we are simply smooshing two strings together or two other data types. Now again, in Python, the most difficult thing for beginners is that of managing different variables with different data types. So I'd like to go ahead and run this and show you what's going to happen. And what you'll see is we get that first error that we discussed in one of the earlier modules. Let's take a look at this error. Type error can only concatenate string, not int to string. So we have this issue here. When we are using the plus sign with strings, we're expecting to shove together or concatenate. However, num1 is still an integer variable. There are multiple ways that we can fix this. The method I'd like to show you right now is that of casting. So I'm simply going to use the function str right before num1. Make sure I both open and close my parentheses. And we are now casting or putting in the role of a string the integer variable num1. Let's go ahead and run it again and see what happens. And now you'll see we actually get the complete statement with the successful string concatenation. We've put together the two strings 2 times 4 equals with a space and the string 8. If we wanted to, we could also add a period at the end like so. Make sure I save and run again. 2 times 4 equals 8. Let's go ahead and move to the second one. So we're going to assign the value of 3 plus 7 to the variable num2. All I need to do is create another variable, num2, and set it equal to 3 plus 7. I can actually copy and paste my print statement if I would like, and change it so we get the following result. So 3 plus 7 plus, in this case, I'm going to use num2 with the period. Go ahead and save and run it, and you'll see I get 2 times 4 equals 8, and 3 plus 7. I need to add my equals text with a space. Let's run it again. 3 plus 7 equals 10. Okay, finally, we have assigned the value of num2 mod num1 to num3. So I'm going to say num3 is equal to num2. I'm going to use the percent sign num1. And I'm going to print to the console. This time I'm going to actually cast all of the variables. So we have the following. I need to cast as a string num2. Let's add a space in the middle. Cast the variable num1. So num2 mod num1. Add the word equals. And finally concatenate the string num3. Let's go ahead and run this and see what we get. So the last sentence, we get 10 mod 8 equals 2. So when we divide 10 by 8, we get a remainder of 2. So at this point, we've performed 3 different mathematical operations. We've discussed casting of variables as different data types, specifically in this case using the string function. And we've also demonstrated string concatenation. I'm going to go ahead and save and share this code to Blackboard. Next, let's take a look at the first flowchart we ever created and see if we can turn it into a Python application. For this example, we're going to need to learn how to get input from a user. So this is the application that prompts the user for a number, multiplies that number by 2, and shares the result. I'm going to go ahead and create another new file and call this multiply by 2.py. I'll write my comment at the top to reflect what the flowchart did. So this application prompts the user for a number and returns the result multiplied by 2. It's always good to comment your code. I'm again going to save to make sure that that dot goes away. And what I'm going to attempt to do is show the flowchart on the left and then the Python code on the right. So we have between our start and stop terminals, first an input prompt. We have our variable number capturing the user's number. We have a second variable result that is set equal to the user's number times 2. And then we have our output that shares the result. So we can approach this in different ways. We can choose to use the legend as a means of setting up our variables beforehand. We can also simply create and assign variable values on the fly. I'm going to suggest in this case that we actually do create them on the fly, similar to the flowchart. So to get input from the user, we are going to use the input function. This looks a little something like this. Again, we have the word input followed by an open and close parentheses. Again, functions can take arguments. In this case, the argument is going to be the text that is displayed to the user when they're being prompted for input. So I'm going to include in single quotes what I would like them to see, and that will look like this. So enter a number. Now, if you're ever in doubt about what a function or an operation is producing, you can print the result to the console. So keep in mind that even though this doesn't look like a mathematical operation, that because it is a function that has a return, it will evaluate to something. So this function will evaluate to whatever the user types in before they hit enter. And we want to make sure that we store what they're entering. So we're going to use the variable number to catch what the input produces. The way this will work is that number will be assigned whatever value the user puts in, even if that value is simply just nothing and then hitting the enter key. To go ahead and see what this evaluates to, let's go ahead and print number. I'm going to go ahead and run this and we'll see the result. It says enter a number. So I will put in the number 5 and you'll see that it prints 5. Now I need to make a special note here because the input function will take whatever value is put in and it will become a string. So the number here is actually a string. It is not the number 5. We can check this by doing the following. Say print number plus 1, save and run it again. If I put in the number 5, sure enough, you'll see that I get an error. So it can only concatenate string, not int to string. So I have to be aware that whatever I put in when using this input function, that it comes in as a string and that the variable that is catching that will be a string. A simple way to prevent this from happening is to just cast the result of the function like so. Similar to that string function that I used, I can use int and simply put the int function, again remembering to both open and close the parentheses, around the input. Functions will evaluate from inside to out. So the input will be evaluated first, followed by the int, the result of which will be assigned to the variable number. Go ahead and save this and run it again. This time when I enter the number 5, you'll see that it actually prints out 6 because it was able to successfully add 5 to 1 and then print the result. So at this point you can see how adding syntax can complicate things. You have to understand how the syntax works, but we are still following the logic of the flowchart. The additional things we needed to understand here is that we are putting our variable name on the left so that we can catch what happens on the right. We learned how to use the input function to catch user input that is put into the console, as well as how to cast that input in the case where we need to use the result as an integer. We could also cast it as a float. There's no need to cast as a string because whatever comes in as input is in fact a string. We are now on this processing box and we can simply type out what is in the box. So we're going to set the variable result equal to number times 2. If we again want to test to see what we have, we can simply print result, save and run that. You'll see that when I put in the number 5, I get the result of 10 because 5 times 2 is 10. Finally, the last thing we need to do is share the output with the user. So this parallelogram here, we'll use the print function to do this and say print number concatenate times 2 equals and concatenate the result. Now you're probably thinking, well, in the reverse, I'm going to get an error here because now number and result are in fact integers and no longer strings. Let's double check that. So we enter the number 5 and sure enough, we do get an error. So now we have to remember to go back and convert or cast number as a string as well as cast result as a string. Once we do that, we can run. See, we input 5 and get 5 times 2 equals 10. So here we have the input function. We've used the simple multiplication operator to store the result of the number times 2, and then finally use the print function to share the result to the console. Again, the trickiest thing here is that you need to be able to cast variables when data types will not work. So when we're printing to the console and we're concatenating, everything needs to be a string. If we are working with mathematical operators, whatever variables we're using need to be either integers or float point variables. Once you're able to manage the casting of your variables, you'll find that using user input is quite straightforward. I will again post this code to Blackboard. Finally, let's take a look again at our final flowchart. Let's again take a look at the compound interest flowchart, in which we take in the principal, the rate, the number of times the interest is applied, the number of time periods, calculate the amount, and then share the output with the user. So this is very similar to the program we just created. The difference is that we're taking in input of multiple variable values, and we're going to use an exponent in this case. We'll use a new mathematical operator. I'm going to go ahead and make a new file and call it compoundinterest.py. I'm going to go ahead and type the description at the top. This application calculates the final amount of compound interest based on user input. Now in this case, because we have so many variables that we're working with, I'm going to suggest starting by initializing them. So I'm first going to initialize each variable, the principal, the rate, the number, and the time, all equal to 0. We have to keep in mind that several of these variables will be float point variables. We will cross that bridge when we get there. The next thing I'm going to do is create input prompts for each of these variables. Now remember that each one will come in as a string, so I will need to make sure that I am managing them accordingly. So because we are going to be using mathematical operators here, and it will likely not be an integer, we're going to go ahead and use the float casting to convert each of these inputs into a float variable. So we'll do this in the following way. I'm simply going to add float with an open parentheses and a closed parentheses around each of the input statements. So this is what I have so far. I've initialized the 4 variables. I'm going to go ahead and also initialize the amount. I then have created inputs and casted each of them so that each of the results will be float variables. So at this point, all I need to do is write out the process here. So it's going to be the amount is equal to the principal times, I'm going to use parentheses to make sure everything is processed appropriately, 1 plus the rate divided by the number. I'm going to go ahead and put that in parentheses as well. I'm going to raise this result to the number times the time power. So to do that, I'm going to use the double star, and then in parentheses, put the number times the time. You can see that everything is essentially the same here. I've added some additional parentheses and used the double star for the exponent. Let's go ahead and test what we have so far, even though we don't have a result. So principal, let's say it's 10,000. Rate is 2.5. Number of times interest is applied, we'll say 4. Number of time periods, we'll say 12. So it looks like we were able to take that input and we did not get any error when running this. If we want to check our result, we can simply add a print statement for the amount and run again. Let's try those same values. So 10,000, 2.5, 4, and 12, and you see that I get a very large number. You'll see that I actually made one mistake here, so this is important to point out. I should have divided the number by the time. I'm not sure why I had that incorrect on the flowchart. The logic is correct, the mathematical operation was incorrect, so just make note of that. Now it comes out correctly. So finally, let's add this string concatenation here. So we're going to print the following. The final amount is plus the amount. And just to remind you that you will need to cast back to string, I'm going to run this again so we can see the error. So the principal is 10,000, the rate is 2.5, applying it 4 times, 12 time periods, and we do in fact get that error. So we can only concatenate string, not float to string. Let's go ahead and cast amount as a string and run one more time. So let me go ahead and add a period as well. So we have principal is 10,000. Rate is 2.5, number of times is 4, and time periods is 12. And we get the final amount is 11,756 and some change. We'll talk more about how to manage currency a little bit later. For now, it's just important that you understand how to work with the different basic data types, including integers, floats, and strings. There's a lot of information here, including touching on the input processing output process, as well as, like I said, managing data types, using variables, and using mathematical operators. So I strongly encourage you to work through these examples and to try some examples of using mathematical operators and taking in user input and producing output on your own. If you have any questions about these examples, please let me know.